Okay, we're back. This is Intro to Stats 189, and we're looking at Review 2. Okay, so the first page there's a lot of definitions. So what are the well-defined results of a probability experiment called? Those are called outcomes. Number 2 is define a sample space that is a set of all possible outcomes of a probability experiment. So, for example, if I wanted to give an example of sample space, when I roll a single die, the sample space is 1, 2, 3, 4, 5, or 6 on a normal standard die. These little squiggly lines on either side is called set notation, and that's how you usually, list the sample space. Define a classical probability that assumes that all outcomes in the sample space are equally likely to occur, and I put down mathematically what should happen. So if I roll the die 60 times, what should happen is I get 10 1s, 10 2s, 10 3s, 10 4s, 10 5s, and 10 6s. That's usually not true, except in the long run. As you increase the number of trials, you go closer and closer to the classical probability. And so classical probability, also known as theoretical probability in other texts, is kind of what should happen mathematically. Define empirical probability. Well, that relies on actual experience to determine likelihoods. So you run an experiment or observe an event to determine the probabilities. And so you could run an experiment. You could legitimately roll a die 60 times and then mark down how many ones did you get. Maybe you get 12 ones. Maybe you get 6 twos. And then the probabilities would be based on that experiment. So if I said, what's the probability of 1, and 12 ones came up in my experiment, it would be 12 out of 60. Okay, so empirical probability, also known as experimental probability a lot of times in, again, other texts. Define subjective probability. That uses a probability value based on educated guess or estimate. So that might be like if you're a sports person, the rankings for the college, they kind of use subjective probability. So, I mean, sometimes Wisconsin Badgers, they win, but then they actually drop in the ranking because the win wasn't all that great, or, it was, or other people did much better in the conference or something. And so that's called subjective probability when you use some other metrics to determine what the likely outcome would be. All right. Define the law of large numbers is number 6. That is, the empirical probability will approach the classical probability as you increase the number of trials. So if you flip a coin 4 times, you'll not necessarily get 2 heads and 2 tails. But if you flip a coin 1,000 times, you'll probably get really close to 500 heads and 500 tails. It will approach the 50% mark. It might be 501 and 499, but it'll be much, much closer to 1/2 than if you only ran 10 trials. All right? Okay, so those are all of the definitions on the first page. Number 7, they want you to, a box contains a 1, a 5, a 10, and a $20 bill. A bill is selected at random, not replaced, and then a second bill is selected at random. Draw a tree diagram to determine the sample space. Okay, so you have a 1, a 5, a 10, and a 20 in a hat or in a box or whatever, and you get to pick 2 bills out. So you pull one out, and we don't put it back in. So if I pull the 1 out, if this is my first outcome, the 1, then there's a 5, 10, and 20 left. And so now at the end of each one of these branches, This would be a 1 and a 5. This would be a 1 and a 10. This would be a 1 and a 20. If I pull a 5 out, then I could get a 1, a 10, or a 20. So that would be 5, comma 1, 5, comma 10, 5, comma 20. If I pull a 10 out, then I could get a 1, a 5, or a 20. Second. So that's 10, 1, so you kind of follow the branch. 10, 5, 10, 20. Okay, and then the last one, what if I get a 20 first? Well, then I could get a 1, a 5, or a 10. So 21 or 25 or 20 and a 10. So $30 is the most that you could get out of this deal, and $6 is the least amount, and then everything else is kind of in between, right? There's $6 again, and there's $30 again, but the max is 30 and the least is 6. Now they want you to list these as a sample space. So then you do the little set notation. And so then we'll go 1-5, 1-10, 1-20, 5-1, 5-10, 5-20, 10-1, 10-5, 10-20, and 20-1, 20-5, and 20-10. And that's our sample space. All right. Okay. So let's look at the second example, number 8. Born male or female. I just went with boy and girl, B and G. So if you're going to have 3 kids, what are the possible, combinations of boys and girls? Well, on the first one, you could have a boy or you could have a girl. Next one, boy, girl, boy, girl. Third one, boy, girl, boy, girl, boy, girl. I'm just went alphabetically. Boy, girl. So now let's follow these branches. Boy, boy, boy. That is a possible outcome. All 3 boys. Boy, boy, girl. Boy, girl, boy. Boy, girl, girl. Girl, boy, boy. I'm going to have to continue the line. I just kind of ran out of word. Girl, boy, girl. Girl, girl, boy. And all 3 girls. Girl, girl, girl. So there are 1, 2, 3, 4, 5, 6, 7, 8 different ways that you could have 3 kids and look at the gender when they're born. So, again, it's not that unlikely. A lot of people, sometimes they want to have both. And so they have 2 kids and they only wanted 2 kids, but they'll try for a third. And, they have 2 boys and all of a sudden they get a third boy. Or 2 girls and all of a sudden you get a third girl. And it's not that unlikely. I mean, it's much more likely that, each one is equally likely. So it's 12.5% chance, 1 out of 8. So that's 0.125. That's a 12.5% chance that'll happen where you get all girls, or basically every one of these combinations is 12.5. Now, if you say, well, the chances of getting at least 1 girl are better, sure, if you're for sure going to have 3 kids, 1 girl, at least 1 girl, that would be 1, 2, 3, 4, 5, 6 ways that can happen. Or 7 actually, 7. So 7 out of 8 ways. And if you wanted at least 1 boy, that would also be 7 going the other way. So, hold on. Okay, so let's look at page to where we're just finding probabilities. Now, a probability is the number of ways it can happen over the total amount. So a customer is selected at random, find the probability that one sweater he purchased was blue. So here, let's get rid of our tree diagram. And you got to read the first part of this problem. It's for all three parts here. Is you have 12 white, 5 red, 2 blue, and 4 yellow sweaters. Okay, and so if a customer is selected at random, that was during a sale, that's what's sold. So if I just randomly selected a customer, what is the probability that one sweater he purchased was a blue sweater? Well, blue, 2 out of, now we have to add all those up. 12 plus 5 plus 2 plus 4, 17, 18, 19, 23. So 2/23 is the probability of blue. The number of ways it can happen over the total number. And so that is 0.47826086966. If you take 2 divided by 23 in your calculator. But then they want, oh wait, I copied down the wrong one. That is not it. It's like 50% chance. That doesn't look right. It's not right. It's 0.0869565217. That's all the numbers on the calculator. 2 divided by 23 is that. We want to round it to the 100th of a percent. So first you make it a percent, and then you round. So to make it a percent, we multiply it by 100. Okay, now 100th of a percent. So tenths, hundredths, and then you look to the third, thousandths. If this is a 5, 6, 7, 8, or 9, you bump this number up. If this is a 4, 3, 2, 1, or 0, you just drop that off and leave that number the same. Since it's a 5, that 9 gets bumped up to a 10, and we get 8.70%. Now, if you just said 8.7%, that would be fine. In tech math, we talk about precision, and so if it's precise to hundredths place, you put the 0 there so everybody knows. But you could just leave it 8.7 if it rounds like this. Okay? Let's look at part B. Find the probability one sweater was not white. Not white. Well, there's 12 white sweaters. And then there's 5, 6, 7, 8, 9, 10, 11 not white sweaters. So we could just do 11/23. Another way to do it would be do the probability of white 12/23 and say 1 minus 12/23, which would be 11/23 again. So either way is fine. That is 0.47826. I'm not going to write, there's more numbers after, I'm just going to write down this much. And so that is 47.83%. So 2 places over, and then you round, that 6 bumps that up to a 3. All right. If a customer selected at random, find the probability one sweater he bought was red or yellow. So red is 5, yellow is 4. So that would be 9 total positive outcomes. Probability of red or yellow is 9 out of 23. Again, if you wanted to do it as like a problem, 2 separate problems, you could do the probability of red is 5/23 and the probability of yellow is 4/23. Or basically means add in the world of probability. So you have common denominator at 8/23 and you add those, you get 9. And then you divide it, you get 0.391304, and that's 39.13%. Okay. Okay. Let's look at 10, 11, and 12. So that is with a standard deck of playing cards. And I list out what is in a standard deck of playing cards. So that is 4 50-seconds. Let's see, it says the probability of a 10 or a jack. So there are 4 10s in the deck, all the different suits. Diamonds, hearts, spades, and clubs. And there's 4 jacks in the deck. So that would be plus 4 50-seconds. And so 8 50-seconds. So again, if you didn't want to set it up like this, you could just say there's 4 of those and 4 of those. That's 8 total out of 52 cards. And then divide. And make it into 15.3846%, and then hundredths of a percent. So tenths, hundredths, we actually go to thousandths place, and don't look past that. Don't make that 6, make it a 5 and go up like that. That's not how we do it. Just look to that one, forget everything else. And so 4 isn't enough to bump it up. So 15.38%. Okay. 1 card is drawn from a deck of standard playing cards. Find the probability of getting a heart. Okay, well, there's 4 suits all equal in amount, so 13 of them are hearts out of 52 cards, and so it's just 13 over 52. And that's actually 0.25. So that one, you didn't have to do all this stuff. You just had to make it 25%. Because it worked out exact. 12. What is the probability of getting a 6 of spades? Well, there's only 1 6 of spades. So 1 out of 52. And so 1 divided by 52 in your calculator is 0.0192307. And so that is 1.92307%, which is to hundredths of a percent is 1.92%. Almost 2%. Not quite. All right. So when you look at the reverse of that, if that were almost 2%, well then the reverse would be 98% that that's not the 6 of spades. Okay, so that was page 1 and 2. The next video will be the next 2 pages.